Okay, so let's pick up where we left off last class. Review real quick and then we'll get started. Hopefully you remember we started a program dealing with queues. And I want to just review briefly what we talked about last class, and then we'll get back to our program. Okay, so let's look at this. Briefly. Am I going to make it? I believe it. I didn't know it was possible for the marker to end up farther away from the trash can than when I threw it. I'm just going to leave it. I don't even want to try it. It's depressing. Go for my card. That was bad. Okay. We talked about the idea of a queue. Okay, and there's a couple things that I want to make sure that we are good on before we get started. So the rules for a queue. Okay, this is review. This is something you should know. The rules for a queue: we add to where? Where do we add? New objects get added to the back of a queue. Very good. We add to the back. Adding to a queue is called what? Enqueue. Very good.
Dequeue.
We remove objects always from the front. This is called dequeue. Enqueue, add to the back, dequeue, remove from the front. What if, in your program, you need to be able to add an object to the middle? What should you do?
Not use a queue.
Not use a queue. Good answer. Don't use a queue. Now, as far as what data structure you should use, you can't really answer that yet. Okay, it depends on other stuff. We will get to that later. At least made it out of the door that time. Thank you. All right. A couple other things. The idea of a base data structure. A base data structure is what? In your own words, tell me what a base data structure is.
Something that you build initially and then can be used to build other structures.
Very good. Very good. So a base data structure is a data structure that can function on its own. You can use the base data structure as is, keep track of objects, using your programs, whatever you need to do. Okay? It works great by itself, but it can also be used to implement other data structures. Okay? Well, we haven't done a whole lot with this yet, but the picture I painted last class was this. You can use an array to create a queue. Because what makes a queue are the specific rules for where you add and where you remove. So, as long as your data structure adds to the back and removes from the front, it's a queue. Now, whether we use an array to set that up or something else to set that up is fine. It's still a queue. But the data structure that we use to create a queue can be different. Okay? And so that brought us to the idea of a base data structure. We are using not an array to implement our queue, but what are we using? Do you guys remember? Linked list. Okay, we're using a linked list to implement our queue. A linked list is a data structure that can function on its own. There are different types of linked lists. And the characteristics of a linked list are each object in the list holds a reference to the next object. Now, this is not indexed. Okay, we'll talk about what that means. So in a linked list, and this is review, each object in the list holds a reference to the next object in the list. It's typically drawn as something like this. Where these boxes are objects, and each box, each object, holds a reference to the next box in the list. And this is different, because this is box 1, box 2, box 3. This is different from an array, where we have box 1, box 2, box 3, and then we have these index numbers. Or if I said, I need to pull box number 2 out, we would go to the array at position 1 and pull out the box. We can do that because an array, just like an array list, is an indexed structure. So if something is indexed, that means each compartment, each element of the structure can be accessed using an index number. You can jump straight to that one. If I want to jump straight to this one, I simply say index 2. Okay? This is different from our linked list. A linked list is not an index structure. I can't jump straight to this one if I want. If I want to get to this guy, I have to first go to this one. This one gives me this one. This one gives me this one. So if I wanted to get access to this, what kind of operation would that be? O, N. Very good. Where N is number of elements. Okay? The operation we would be doing was getting the next, getting the next, getting the next. What's the cost to access this guy in an array? O1. Doesn't matter how many objects there are. If there are a billion elements in an array, what's it cost to pick out one of them? O1. It's the same cost every time. Doesn't matter how big the array is. Now, there's other differences between the two. We'll get into that later. What I want you to understand more right now is how a linked list is structured. Each object holds a reference to the next. Any questions on this? This is, again, a review. Good? All right. We are going to get into your program again. We're going to pick up with where we left off, which is adding objects to our queue. But before we do that, I want to give you guys a chance to ask any questions about your programming assignments. We talked about it last class. We assigned it last class. If you haven't looked at it, it's on Canvas under assignments. You are creating a grocery store simulation with customers waiting in line. No questions? Everybody good? All right. Well, if you have any questions in the next class periods, feel free to ask. All right. So the program that we set up was something similar. Instead of customers waiting in line in a grocery store, we have customers waiting in line to buy snow cones. Okay? Certainly not as complex as what you were doing for your assignment, but same idea. Customers can show up and they get added to the queue. We're not actually setting up a 60-minute simulation where customers have service times and that sort of thing. The purpose of this is simply to show you how a queue functions, where you add an object, it goes to the back of the queue, you remove an object, it gets removed from the front. Okay, using this information, you should be able to expand on it and do what you need to do for your programming assignment. All right, so open our project back up. Let's kind of review the code that we've got so far. Is this big enough? Can you guys see this? We have 3 classes seen at the bottom here. We've got our linked queue. This is the class that we wrote for our data structure. Okay. We have our customer class. This is the class for the object that we are instantiating over and over again, and we are actually going to be putting into the data structure. Okay, so customer objects we're going to instantiate and add to our queue. Finally, we have our snow cone store, which is our driver. contains the functionality for creating the queue, adding the customers to the queue, removing them, and so on. Right? So let's start with our customer class. We've got a string for their ID number, and we have a reference to the next customer in the list. When we first create the customer, we randomize their ID number from 0 to 99. We have it set up as a string. The other thing that we should do here that we didn't do last class is when a new customer object is created, we should go ahead and set their next reference to null. Now, in Java, we don't need to actually type this line of code. By default, the default value for any reference variable is null in Java. Not all languages do that, so it's a good idea to get in the habit of doing it. If we left that line of code out, it would still work fine. It would default to null, but it's a good idea when we go ahead and create our customer object in the constructor to set next to null. Questions on that? Okay. What we have left in customer is a get next and a set next, and finally a two-string number or two-string method that outputs their ID number, or just returns their ID number. Okay. Running over to our driver, first thing we do is we create our queue. We instantiate an object of our linked queue. We just need one. We have one line. And then we loop through and we add 5 customer objects to our line. We create the customer object first, and then we pass to the enqueue method the location and memory to where that customer object was created, which effectively passes the customer object. Okay. Again, any questions on this? This is where we stopped. Okay. We stopped because we are now passing our customer reference to our add method, to our enqueue method, which we need to handle in our linked queue class. Okay. So, just a few things to keep in mind as far as where you put the code for this stuff. You always want to put the behaviors that are being done to or being done by an object in that object's class. Okay, so for example, in our queue class, we are adding to the queue, so that process of adding something to the queue needs to be coded in the queue class. Okay, does that make sense? This is something that is tricky for people when they first start out coding. It's tricky for people who've been coding for years. You know you have code that you got to write. We know we need to add people to the queue, but where do we put it? We could put it anywhere. You know, we'd have to mix around some references, but we could really put this code anywhere. But where does it make the most sense? And this is something you will learn more as you code more. We're going to put it in our queue class. Okay? All right, so let's look at what actually happens. We know that we're passing a reference to a customer to our enqueue method. And as we pass it in, that reference gets stored in the variable C. Okay, so C is the customer that we are adding to the queue. Okay? And so let's take a look at what is going to happen. Try to decide whether I want to do it forward or... Let me try it. So I'm going to give you some programming advice. Whenever you are coding something that you've really never coded before, like this. Anybody coded this before? How to add to a queue code. Whenever you're doing something like this, you should always write out in some form how it should behave under different circumstances. Okay? Unless you know what it should be doing, it is very difficult for you to code that. Now you say, okay, I know we want to add to the back. Let's just start figuring it out. Take a couple minutes and plan it out, and you'll be much better off than if you just try to start coding it. Okay? And when you're doing this for a data structure, so when you're trying to figure out the add, remove, search methods for your data structure, the way you should do this is look at, categorically speaking, look at the different configurations of the data structure at the time that you're going to go add something. For example, if we were to add an object to the queue and the queue were empty, what should happen? If we go to add something to our queue and there's only one object in there, what should happen? If we go to add something in the queue and there's a bunch of objects in there, what should happen? So draw that out and then use that planning to help you code. It'll go much easier than if you just tried to start writing. Okay, you guys remember when you were like in English class and they said, plan out what you want to write before you write it? I used to hate that. It'll go much better, okay? It's true for coding. I'm going to show you how to do it. And so, set up just a really basic chart like this. So, we've got before we add and after we add. Did I really spell before like that? So, if our queue is empty, it looks like this. First, points to null. Last, points to null. Make sense? First and last are properties of our queue. First always points to the object that's in the front of the queue. Last always points to the object that's last in the queue. If there's nothing in the queue, these are null. They don't point to any object. So this is the situation before we add. After we add, it should look like this. First points to an actual object. That object points to null because there's no other object in the list. And last also points to the object. Okay? Because it's possible that one object is both the first and the last one in the list. Right? If you're the only person in line, you could say that you are the first person in line, you're also the last person in line. Make sense? Good with that? All right, situation 2. Okay, so this is when our queue is empty. This is when there's one object in the list, or the line. First points to the one object in the line. That object points to null. And last also points to that one. I'm going to put a 1 here so we know that that's the ID number. It could be a million, it doesn't matter. Okay. So if this is the state before we add, let's draw what it should look like after we add. Okay, so we add a new object. First still points to 1, because he was there first. Okay? 1 now points to the new object that we added, 2. 2 points to what?
Null.
Null, very good. The last one on the list. Last used to point to 1. Now where does last point? 2. 2, very good. All right? Moving on. We'll say 3 objects in the line. We've got first, 1, 2, 3, and this is really, you got a bunch. It can be 3, it can be 5, it can be a million, doesn't matter. Okay. This is the configuration when we start. After we add a new object, we have first, we have last, we have 1, points to 2, points to 3, points to 4, points to null. Any questions on this? If you take, how long did that take us? 5 minutes? Not even? This will help you out tremendously. Is there a way to like save it?
I think you could click a little further down.
This one?
Yeah.
Saving. Where did it save?
That's a good question.
Go to file, look at locations.
Here we go.
Go to paint and just copy and paste it.
Hey! So I took a screenshot of it. We'll just do that from now on. Files. Alright. There we go. So now, let's code it. So, when we say let's code it, here's what we're going to do. We want to look for common things that are happening. Specifically, let's look at what happens with the references, first and last. Okay? So, whenever we add an object, what happens to the first reference? Look at what happens. In this case, first was null, and now it's the new object. In this case, first was 1, and now it's the same object. In this case, first was 1, and now it's the same object. So what can we conclude from that?
Next is pointing towards the next. Next is pointing towards the next object. Next reference in the object.
When you say next, next of what? Next of first?
Yeah, the one.
First next. Okay, good. So if we look at this, first points to the next object. Okay? Now, look specifically at what first is pointing to. Does what first points to change? Does it change in this one?
No.
No. First points to 1. After we add, first still points to 1. Same thing down here. What about the first situation?
Yes. No.
Right. It was null. After we add, it's the first object in the list. So, we can make a conclusive statement that says, if the list, we'll say if the queue is empty, first should reference the new object. Do we agree with that statement?
Yes.
Right? So, step 1, we drew it out. Step 2, we analyzed it and came up with a statement that we can make like this. Now, we could say, if the list is not empty, first reference doesn't change. But we don't need to code that. If we don't tell it to change, it'll stay whatever it is. Okay? So, how do we code this? Can we code this? Okay. Look at the first part. If the queue is empty, do we have any way to determine if the queue is empty?
No.
Let's look. Go back and look at our drawings. Is the queue empty in any of these drawings?
Yes. When the first and last, are null.
When first and last are null. Certainly. Can last be null, but first have a value? Is it possible for there to be someone in the front of the line, but not the back of the line?
No.
No. So we could simplify that statement. It's very true, if first and last are null. But we can simplify it and say, if first is null, the line is empty. If no one is in the front of the line, it's empty. And we could make the same thing about the last portion of the line. A lot of times what you'll see are little helper methods called isEmpty. that return either true or false, depending on whether or not the line is empty. This is easier to read than the actual code for determining if it's empty, which is why we do it like this. Now, we could say if first equals null, return true, else return false. Right? If first is null, means no one is in the front of the line, then the list is empty. So we return true. Good with this? Now, we can actually simplify this code to this. Get rid of this. Now, look at this. When you guys first learned coding, you were taught when you have a conditional statement, if, and then here's your conditional statement. This has to break down to what? 0 or 1, or true or false. Good. Either way you look at it. Okay? So this breaks down to true or false. If it's true, we return true. If this is false, what do we return? False. So we could really return the result of this statement, which is what we did. Okay? Does that make sense? When we have first conditional operator null, if this results to true, we return true. If this results to false, we return false. Again, there's nothing wrong with doing this. It's just more code. You don't need it. We'll leave it like that. Good? So now we can come down here and say, if is empty, that handles this first. If the queue is empty, first should reference the new object. How do we do that? All right? That is correct. C, which is the reference variable that holds the location and memory to the object that we are adding, C gets assigned to first, where first is another reference variable that points to a customer object. Questions on this? All right. Back to our notes. So we handled adjusting the first reference. Now let's look at the last reference. Look at what happens between adding with the last reference. Here, last started out being null. Here, last pointed to the object that we added. Okay? Here, last started off pointing to 1, and it ended up pointing off to 2. Here, it started off pointing to 3, and it ended up pointing to 4. So can we make a statement about what we observed with regard to how the last reference gets changed when we add an object? Who can make a statement?
It always equals the new object.
Bingo. Very good. Last always equals the new object, no matter what. So last should always reference the new object. How do we do that? Last equals C. Very good. Last should always reference the new object. Good so far. One other thing we need to look at. So if we go back and we look at our notes, there's 3 things that can change. First is the first reference. The second thing that can change is the last reference. We wrote lines of code that handled those. But there's one more thing that can change. What's the other thing that can change?
The number of objects.
Okay, so good. When we add a new object, what happens? Specifically, look here. we started with one object, we added another object. What changed besides drawing a 2?
More last.
Okay, so last change, good. We handled that. Look right here.
No.
Oh, the reference.
Yeah.
Right. 1 used to point to null. Now it points to 2. 3 used to point to null. Now it points to 4. Who can make a statement that sums up what's happening there?
C equals last.
Say that again?
C equals last.
C equals
C equals
First.
something.
no.
No?
Well, no. So look what happened. Look what's happened. What does this arrow represent?
A reference. Something referencing.
Whose reference?
First referencing the last.
Good. So this is object 1's next reference. So we are changing the object's next reference from pointing to null to pointing to the object that we just added.
C.
How do we access this object?
C.
C is 4. C is the new one.
Yeah.
Okay? So in this situation, C is 2.
Yeah.
In this situation, C is 4. In the blue situation, C is 1. So what we want to change is not C's next reference, but what object's next reference?
No.
First.
Not first,
It would be last.
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 Yeah.
Look, we want to change 1 here. We want to change 3 here. Both of those are referenced by last. And if you think about this, if you're waiting in line and you're the last person in line, currently no one is behind you. So your next reference is null. But when somebody new gets added, the person that's last in line
Not last.
is no longer last. So their next reference changes to the person behind them. Okay, does that make sense? See a lot of that.
Yeah. Yeah.
So, how do we access this guy? 1 and 3.
Last equals.
Last. Okay? So this is important. Now, we have to put this line of code before this line. The reason here is we're changing who's last in line. And so what we want to do is, before we make last point to the new object, currently last points to 3 here, and when we're done we want it to point to 4. Before we change last pointing to 4, we have to set the next reference of this guy. 3 needs to point to 4 before we adjust last. Because if we do it out of order, we'll lose the ability to reference him. Because once we change last to point to 4, we can't access this guy anymore. Okay? So we have to change the last object's next reference before we change what last reference is. Okay? So that's why this has to go before here. So we'll say, before we change last to reference the new object, set the current last object next reference to point to the object. It's a lot of comments, but I want to make sure that we understand what's happening. And this is the last line of code. It's not a ton of code to do this, but I want to make sure that we understand it. That's why I'm going real slow and putting heavier comments than I normally would. So we know we want to change the last object's next reference. So we're going to say last dot next
C equals C.
equals C. Now, logically, this makes sense. Next is a characteristic, it's a field, a variable, of the customer at the last position in the line. But we're not allowed to do this.
Oh, we have to do the.
Right. And so if you look at how we have this, go over to our customer class, next is declared private.
Last dot set next.
Right, so we have to use our get next and our set next methods. Okay, so we're going to say last dot set next passing C. Okay? Just do lowercase, sorry.
That's the same. Get rid of the equals sign.
Questions on this? Let's compile it and see if we've got any errors. So we got one error. And it's
Where?
yelling at us that we don't return something in our dequeue method.
Right there.
I'm just going to put return null right now, just so that it satisfies our compiler. We're not calling dequeue yet. So we run it, and we crash. Why do we crash? Now, it tells us we crashed on the line of code we just wrote. Okay, so let's look at the error and figure out what happened. It says exception in thread main, java.lang.null pointer exception. So this is the error that we got. We got a null pointer. A null pointer means we are trying to access an object that doesn't exist. So you have a reference variable. Reference variables point to objects in memory. If you try to use that reference variable to do something, but it doesn't actually point to an object, you get a null pointer exception. That's what we got. At, so it tells you where the error occurred, the enqueue method of the linked queue class on line 24. Okay? This gives you the call stack. So we called it on line 19 of our driver. Okay? So, remember, what we're doing is we are updating the reference of the object that is last in the list. Works great here and here. What happens in the first situation? Right. So, right here, it's saying take the object that's last in the list and set its next reference. So we're trying to call set next on an object that doesn't exist. So that'd be like if you're working at a grocery store and you lean over and you tell your line, you know, the next person in the line is the person behind you, but no one's in the line. People are going to look at you like you're crazy because you're talking to nobody. And that's what's happening here. We're trying to tell somebody that's not actually in the line to change the next reference to the next person in the line. So how do we solve this?
Come from the first one. Let's go first.
If is empty is not false. Or if is empty is false. If it's not empty. Can we just do this?
Yeah.
Does that work? This is where you just compile and hope it works. This is fine. We can do this. Recompile, run, and nothing happens, which is good. Now, here's the thing. Remember in the beginning of the semester when I told you guys, use whatever IDE you want? I recommended like NetBeans or Eclipse or something like that. I said, I'm going to use JGrasp. JGrasp is terrible. But it has one redeeming feature, which is its canvas viewer. And this is where this is going to come into play. JGrasp is great for teaching. And so what I'm going to do is this. Normally we compile with this and we run with this, but I'm going to go two more over and I'm going to click on that little poster board type thing. And that's going to pop this up. Right? And what we're doing here is we're running the program, but we're running it in canvas mode. Okay? And when that popped up, we had this little side panel that expanded too. Okay? This shows you the variables that are currently in memory. And it also gives us some tools in this little canvas window right here. So what's going to happen is, you'll notice that we've got a line of code that's highlighted in yellow. The program is paused on that line of code. So this is kind of like debug mode, if any of you have messed with that before. We're paused on that line of code. We haven't executed it yet. We're paused. Okay? And I've got these controls that let me go through the code when I want it to. So what I'm going to do is I'm going to let it go ahead and create this linked list. All right, so I'm going to click on this Step Into button. which is going to run the next line of code. Where are we going to go from here? What is the first line of code that's going to run when we hit this? This one right here. Where are we going?
Are we going to link queue to make a new object?
If we're breaking this step by step, we are paused here, we haven't run this line of code, where are we going to go from there?
Into the link queue.
It's gonna go into the queue class.
It goes into the linked queue class. What method in the linked queue class?
The constructor method.
Very good. We're going to go to the constructor of the linked queue class. So I click there. We pop over to our linked queue class, and here's our constructor. So we set first and last to null. Finished. Where do we go back to? Back to the driver. Good. So now that we're here, the last thing that we're going to do is set line to reference the linked queue class or the linked queue object that we just created. We do that. Notice that it popped up over here. Okay, now we have our line, which is a local variable specific or local to the main method. What we can do is I'm going to click and drag this and drop it in our canvas. See it pop up here. References first. Now, this is great. It's got some limitations. I wish it also showed last, but it doesn't. But we can get it doing some things. So now what we're going to do is we are going to hit our for loop, and we're going to go through, create a customer, come back, and now we're going to take that customer and we're going to pass it to the enqueue method. Okay? So let's look at what happens right here. I'm going to go into so here's our last reference. We'll pull last over here. I wish it showed it in the main window. It doesn't. It's just going to show it here. That's okay. So currently, first is null. Last is null. Local variable C, this is what we're adding. We're adding a customer who has ID of 42. What do you think this represents?
Null.
Right. This is null.
Last.
What on the customer does this represent?
The next.
The next. Very good. This is the customer's next reference. Currently, it's null, as you guys pointed out, because it doesn't reference anybody yet. Okay? So what we want to do is, here's the local variable section, and here's our line. First is null. So the first thing that's going to happen is it's going to say, if is empty. Do we expect this to be true or false? True. So we go up to the isEmpty method. It returns true. We enter that if statement, and we set C as the first object in the list. Okay. So now first references C. Okay, that new object, customer 42. Good so far? Okay. The last thing that we're going to do, so we skip over this, because there's no object that wasn't last that we need to set the reference to. So now we set last to C as well. Okay, so now last points to 42 as well. Okay. Good so far? Back to our driver. Create a new customer, set its ID, set its next to null, come back, take that customer, we're going to add it to the queue. Okay? So now we've got customer with ID 95. We're going to check to see, is the list empty? Is the list empty now?
No.
No. So it returns false, and we skip down to the else statement. Okay. We say last dot set next to C. So before we look at what's happening, what do we expect to happen? Does 95 go after or before 42? It goes after 42, right? It's a queue. We add to the back. So last dot set next C. Last is 42. So we are accessing customer 42, and we are going to set its next reference to C. C is 95. So we're going to set next, and now it gets updated. All right? So first, 42, 42 references, 95. Finally, the last thing we do is we update last to now point to C. You got a
Can
question?
you scroll up on last?
Scroll up.
Yeah, I can't see last anymore.
I don't think there's anything here.
No idea. That's weird.
It'll change once we do this last on the code.
Okay.
Once C gets removed from memory, it'll change. So, after we finish that one, first reference is 42. That's the first object in the list. 42's next reference is 95. 95's next reference is null. And last reference is 95. Let's do another one. Create a new object. Add it to the queue. So now we've got 65. 65 should go after 95. Okay? 65 goes after 95. The last object in the list is now 65. The first object in the list is still 42. Good? Here's another object. Now we've got 63. 63 goes after 65. And it becomes the new last object in the list.
Gonna sort this one.
Okay? Add one more.
Gonna sort
We
this
get
one.
30. 30 gets added to the list and becomes the last object. Could we do this forever?
Yeah.
Pretty
Sort
much.
of.
Okay, and this is nice. We didn't have to tell the queue how big to be. It's automatically going to size itself. Okay. We good with this? Yes, sir.
So with this data structure, based on the program, we can take away the first one, and it's like independent from what's going on the backside.
Yep. Yep. So, let me ask you this question. What is the cost? I want you to take 15 seconds. Don't yell out any answers. Take 15 seconds and think about what the cost, the complexity, what, for adding an object to a queue. Think about it. Right? Is it O1, On, O log n, On squared, On factorial? You tell me. Think about it.
To the queue.
Adding to a queue, yes. Remember, big O notation shows the relationship between the basic operation and the input size. The input size of a data structure is the number of objects currently in the data structure. So does the number of objects in the data structure affect the number of operations? Yes or no? Let me say it again. Does the number of objects in the data structure, so if there are 5 or 5 million, does the number of objects in the data structure affect the number of operations it takes to add an object to a queue?
Actually,
Yeah, it does. So you have to look at all the others.
Look at the code. Look at the code.
I think.
Do we run more operations if there are more objects in the queue? So if I have 100 in the queue, and I'm keep asking these questions because I'm keep getting mixed answers. If there are 100 objects in the queue, look at how many operations we run. And then if there are 1 million objects in the queue, look at how many operations we run. Does that number change? No. So the number of operations is constant. It is unaffected by the size. Therefore, we would say the complexity or the cost to add an object to the queue is O1.
And oh, yes, yeah, that's
On means that there's a linear relationship, which means as the input size increases, as the number of objects in the queue increases, the number of operations to perform the add method goes up by the same amount. It's going to increase as well. So the more objects in the queue, the more operations it takes to add. That's an On. Okay, and it's a 1-to-1, the linear relationship. I increase by 100 here, the number of operations increases by 100. We see the input size increasing, but the number of operations staying constant. That's why we get O1. Does that make sense? Any questions on that? You need to know that. You need to know not only what O1 means, but you need to know that the cost for adding to a queue is O1. Question?
How, I'm sorry, so how again is it 01? Because if you have, I'm just confused on how the logic for that is. I don't-
Okay, so looking at the code here, what would you say the basic operation is?
It's the last that's it next.
Sure. Okay, whether it's this or this, it's going to run the same number of times. Okay, this line of code and this line of code runs the same number of times. Okay, so when we are looking, let's just say this one for example. When we are looking at this, you have to look at how this line of code, how many times it runs, how that is affected by the input size.
So just that piece right there?
Yes.
Okay, I was thought if you incorporate before looping the driver and all that stuff.
No, no, no.
Okay.
We're just looking at the add method.
Yeah.
Okay? Does that make sense now?
Yeah.
Good. All right. Yeah, it's just the add method.
Okay.
Does everybody else understand why it's 01? Are there any questions on why it's 01? Okay. So now, I'm going to end this. Close out. Let's go back to our driver. So after we add 5, I'm going to remove 2 customers. We say line.dequeue. And in fact, if we look at line.dequeue, notice that I don't pass it anything. Why don't I pass it something? Don't I want to specify what customer I want to remove? Yeah, it's got to be whoever's front line's coming out. If your program needs functionality, don't use a queue. What makes a queue really fast, 01, which is as good as you can get, is the fact that it's got really rigid rules for where you can add and where you can remove from. The more functionality you need, you lose out on some of that speed. Okay? So, I'm going to remove a customer. I don't have to specify it, but if we go and we look at the dequeue method, notice it returns the customer object. So all that I'm going to do is, I'm just going to output it. System.out.println, line.dequeue. So I'm going to output the customer object, which in Java by default we'll call that object's toString method. Okay, so it's going to output the customer that we removed. And I'll just put a quick message, removing the object that we are removing. Good? And I'm going to do this twice. Now, let's go write our dequeue method. Okay? So, take 5 minutes and see if you can code this. We want to remove from the queue. We walked through the process of how we figure out how to write the code for adding. Draw out the chart. What's it look like if it's empty and we try to remove? What's it look like if there's one object and we try to remove? What's it look like if there's a bunch of objects and we try to remove? Draw the before and the after, come up with statements. Based off of the statements, come up with lines of code. Okay, so take some time and do this. I want you to have a chance to interact with this code before we do it together. Yes, ma'am?
Can I just see the customer class again?
Absolutely.
Okay, just don't check it out. So, first, this. So instead of being start step next, it would be first dot. What's the word for removing? What's the command for removing? It'd be first dot something that removes it. First. So you're saying just change this to first? No. It wouldn't be first dot. It would be fill in queue dot remove, the command remove, and then the first object, because that's the one that we're working on right now. So that will be that should be removed inside the parentheses.
Only 13,
So consider that every object has a set number. Let's go to that set number before we remove it. So if first is equal to 0, then the operation to remove.
So to remove it would be first or after?
Maybe link queue dot something and then inside the parentheses. That would be good. That's not what I think. We didn't call, I don't know if we called it link queue or not, but just
Wouldn't it just be the
I could be wrong, I was sleeping for the last 30 minutes.
All right, take another minute.
Leave it.
Oh no, I can't code until I sit down in the room by myself and just start talking to myself. Especially does that when I code. I sit there and talk to myself.
All right, let's get into this. I don't want to run out of time. So let's come over to our linked queue class and look at the dequeue method. Now, what do we do if the queue is empty and we try to remove it?
Nothing. It stays the same.
Okay? Well, we have to return something because we tell it we return something. So we'll have to return null. So typically what a good idea is just to output a method. So if is empty, so if our queue is empty, now be nice with your messages. System.out.println.
There's
nothing there, stupid.
We'll just say the queue is already empty.
The queue that already.
Followed by, I mean, if you want to help encourage, I should say discourage this type of behavior, then you can output or add on to that message to the user. All right. Now, if it's not empty, so if we get to this point down here, then we know that there's at least one object in the queue. Okay? So what happens to the first reference?
It point to anything. It becomes.
If there's one object in the list, what should first point to?
No.
If there's two objects in the list, what should first point to?
First up next.
First up next. Okay. So we agree, if there's one object in the list and we remove it, first should now point to none because there's nothing left in the list. If there's two objects in the list and we remove the first should point to the second object in the list, which now becomes the first object in the list. In both of those cases, if we set first to point to first.getNext, that gives us the same thing. Because in the first situation, when there's only one object in the list, first next is null, right? So if we set first equal to first.getNext, that's null, right? So we will say set first to reference the current first object's next reference, which is the current second object in the list. Does that make sense? Remember, read it right to left. First.getNext gets the customer reference that first currently references. Okay, so if we go back and we look at our drawings, if we started off with this, and this is what happens after we remove, after we add, but if we remove this instead, okay, if 1 gets removed, first should simply point to 2. Okay? Here, if we remove first should simply point to null. In both of these situations, we want first to point to what is next, right? We don't have to handle this because we already handled that in the if statement with the output message. Okay? Good? Now, is there any other thing that we need to do? What about last? Do we ever change last? Do we change last here?
Yeah, we added an object.
If we remove this, does last change? No. If we remove this, does last change?
Yes.
Yes.
That's it, we do that one.
In this situation, if we remove first, does last change? Yes. So, go back and look at this. This is the only situation where we update last. The only time where the last person in the list changes
First
is
equal
when
to
the
last.
line goes from having 1 person to no people. That's the only time last changes. So we can identify this situation by checking to see if,
Is empty.
very good, we can check to see if is empty, last equals null. We could also say if first equals null, but that's the same thing as is empty. So it's better to use existing methods rather than write the code. So very good. Good with this? Now, what do we want to return at the end? We want to return the object that we removed. So the way we do that, we're going to store a temporary reference to the object we want to remove. And the reason we have to do this is because as soon as we change first, we lose a reference to that object. And if we don't store one ahead of time, we're going to lose the ability to reference it. Or, in our case, lose our ability to return it at the end. So we're simply going to say customer temp equals first. And then at the very end, we're going to return temp. Good? I know we went through that last one a little quickly. So let's go see how it works. Compile. No errors. I'm going to pull it up in Canvas. All right. Create our queue. It put up the random. All right, so we're going to create our queue. We'll draw it here. And I'm just going to let it play. Creates customer object, adds that customer object to the list. First now references customer 49. Next object gets created. We pass it. It gets set next. 2.7. 1.5. Notice customer objects keep getting added to the back of the line. Last one gets added to the back, and now here's what we're going to remove. We expect 49 to get pulled out. First to now reference 2.7. It does. Okay? Same thing with 2.7. It should get pulled out. It does. And then our program ends. Okay. Notice it tells us the two that we removed. Okay. Now, here is, I'm going to close out of this, save it. I want to actually go ahead and remove all customers. So we are going to remove all of the customers there. And then I'm just going to say line dot enqueue. So I'm going to add 5, remove all 5, and then add one more, just so we can test out being able to remove the line completely and empty the line out. Okay, you have a question?
So if you didn't know how many customers were in the line, but you wanted to remove all customers, could you do a while loop and just run it until isEmpty returns true?
All right, so I'm going to just let it play. I'm going to let it run a little bit faster so we can see. So it's going to add 5 objects. See, it's adding them as it should, like we expect. And then we're going to remove all 5. Remove. Remove. Notice it's removing from the front like we expect. It's outputting which one it's removing down here. We remove the last one, no errors, and then we're going to add one more back to it. Okay, just to make sure that we're good. Okay. Question?
Going off of his idea, would you be able to use something like a while loop, doing that kind of removal method for the idea that we have to incorporate 1/4 chance to removing customers?
No, you shouldn't do that.
Okay.
All right, last thing. What is the cost to remove from a queue? If we look at the code for removing, it's your last question. There's enqueue, there's dequeue. I'll give you a hint. Is there a loop? If there's not a loop, chances are it's O1. O1, constant time, good. Okay? Remember, if there's a single for loop, it's most likely ON. 2 for loops nested and squared. Input size shrinks by half, log n. Okay? No loops, O1. Okay? Alright, here's what we're going to do. Keep working on your program over the weekend. Next class, we are going to start stacks. Stacks are very similar to queues. Different rules for where you add and remove. We will write a program from scratch just like this, and we'll talk about the concept of searching. Okay? Any questions for me? All right, have a good weekend.